This is the first look video of the ME1130, Essentials of LTE and LTE-Advanced. 5G is the most disruptive trend of this decade. Although 5G technology is starting to deploy, it is coming online much faster than analysts predicted just 2 years ago. With 5G research progressing at a rapid pace, the standardization process has started in 3GPP. As the most prevalent mobile broadband communication technology worldwide, LTE constitutes an essential piece of the 5G puzzle. As such, its upcoming releases, Release 14 and Release 15, are intended to meet as many 5G requirements as possible and address the relevant use cases expected in the 5G era. Many elements of current 5G technology build on 4G networks rather than representing a complete departure. In fact, MIMO, carrier aggregation and QAM are already going into 4G networks, but they play an important role in 5G too. Targeted at 3rd or 4th year undergraduate, the ME1130 serves as a ready-to-teach package for in-depth understanding and hands-on experience on LTE and LTE-Advanced technologies. Introducing the ME1130 hardware kit. Our training kit is built with an Intel NUC Mini PC, an SDR Mini, and an LTE USB dongle. It uses the PC-based implementation of LTE's eNodeB and EPC. This powerful platform allows students to explore LTE protocols and learn how to build a standalone LTE network. The hardware kit is a standard compliant implementation of a subset of 3GPP Release 10 LTE for UE and a base station. A software-defined radio is used as the RF front-end of the LTE eNodeB. In order to comply with various countries' requirements for wireless devices and to avoid getting interfering signals from the public network while experimenting with the setup, this setup uses a direct RF cable connection instead of over-the-air transmission. GNU radio with another SDR is configured to be a signal analyzer to provide LTE spectrum analysis capabilities. This powerful and flexible platform is useful for both teaching and research. ME1130 Lab Overview. In Lab 1, student will learn how to simulate and deploy highly capable real-world software-defined radios and perform LTE spectrum analysis using GNU radio and SDR. In this lab, the Mini PC, Intel NUC, and SDR will form a LTE base station so that a downlink LTE signal will be transmitted. The signal will go through an attenuator and be received by the SDR Mini. A Windows PC with GNU radio will be used for analyzing the spectrum of the received signal. Here's an example of the screenshots of the LTE spectrum scan in band 3 and the waterfall plot. Next, the students will get to set up, configure and implement the eNodeB and EPC using OAI and establish a working LTE network using COTS, UE. Students will then learn how to recover the symbol timing and compensate the timing and fractional frequency offset for the FDD LTE downlink signal. In Lab 4, students will implement efficient detection techniques for some simulated signals and a live captured FDD LTE downlink signal to discover the physical layer cell identity. To get service from the network, a UE has to select the network and camp on a cell. In this lab, students will learn to inspect the data packets traveling back and forth on the LTE network. Finally, the students are going to evaluate the LTE network performance in Lab 6, measuring and analyzing the TCP and UDP throughput and latency of the LTE network. Please visit our website for more information about ME1130. You can also view how a lab is being carried out from the labs on video at our webpage. And you can also download the ME1130 datasheet at our webpage.